Hello, this is Aaron Bryant, and I did my video presentation on distributed password cracking. Some of the background information before I do my demonstration, I'd like to go over clustering. In general, there are three different types of clustering. The first is called failover clustering. Normally, failover clustering is used in terms of two servers. One is the main server, and the second one would be the failover cluster. Both servers are the exact same in image, and they're just put into a cluster so that when the first main server, for example, if it had a bad hard drive or something like that, and some problem occurred where something failed inside of it, so it went down, the other cluster behind it would then come up as the main server, so there would be no loss of productivity time or uptime in the server. The next main type of cluster is a load balancing cluster. The load balancing cluster can be used in both servers and in lab environments. In servers, for the same example, if there were two servers, a load balancing cluster would, if the first machine, became overworked and it needed more resources, it could then balance itself onto the second server in that cluster so that the resources would be evenly distributed and the workload would be decreased on both, so that time would be saved and speed would be increased. This also could be used in the lab environment. The lab environment, it would be more if there was many machines in the lab and a few of them needed more resources than were allowed on that machine. The resources from the other machines would be shared. So in general, all the resources on all of the machines are shared with each other, and it's balanced out. The next type is a compute cluster, more commonly known as a Beowulf cluster. This is what I'll be demonstrating today. In a Beowulf cluster, there's generally a server and then many client nodes. The server may also be a node in the cluster, but it doesn't have to be. What it generally does is it's a management server that sends out jobs to all of the client nodes and makes the job faster by distributing it evenly throughout all of the different clusters. Other terms for the clustering in our terms are parallel and distributed. They are all used interspersed in this sense. The most common clusters in terms of password cracking are cluster knopics with Cecilia. Cecilia is just like John the Ripper. It is a password cracking software that can be run in the terminal, and it can be distributed over a cluster of computers. And cluster knopics is just a live CD of OpenMo6, which is a clustering Linux distribution, and so it makes it easier for Cecilia to be distributed with that Linux distribution. mpitch is another way to distribute those jobs to the clustering and doing the clustering. And mpitch and John the Ripper both are generally used together, and they can be run on either Windows or Linux, both. It's best to run them on Linux because it has more functionality and can be changed in more ways to fit your needs. But for demonstration's sake, we will be using a Windows machine. So here we have our Windows VirtualBox, and I would first like to demonstrate mpitch. The first part of mpitch when creating a cluster will be to configure the cluster. Here the computer is named Tyler, and it's Tyler-xpvm. And for the sake of demonstration, I won't be connecting other machines to this one. I'm just demonstrating mpitch. It has a nice feature that if you are in a domain is selected, you can click Scan Hosts, and it will scan all the machines in that domain for any that have mpitch also running on them. This is handy and it makes it easier to configure a cluster than a lot of other softwares where you have to specify IP addresses for each client and the server. It also has a nice function where you can scan for versions. This makes sure all of the client nodes are up to the same version of mpitch so you don't run into problems, and allows for easier clustering as well. Once you have this done, then you can click change any of the settings you would like to change for your cluster, and then all you have to do is click apply all, and it applies them to the cluster and creates your cluster. The next part is registering, which is done so that when you send out a job to each machine, it has an account to run on. So the account needs to be created ahead of time on each machine. It could be an administrator account or just another account for this purpose. Here you put in the account name and password and then click register. This makes it so that all the jobs sent out will be able to run on each machine without problems. And the final part to mpitch, once you have your cluster created and now it has a user account to work on, this is where you can create and add the application of John the Ripper into it. Here we add our application, and then all you do is you load the job, which would be the password, and then you click execute. And that adds John the Ripper to mpitch so that John the Ripper commands can be sent through mpitch. So now that we have our cluster, we have everything set up for John the Ripper. Before we can actually run John the Ripper, we have to have passwords. The program I chose to use is called fgdump. This program, what it does is it captures the local machine's passwords, but it captures the hashes and it puts them into a text, or it puts them into a file. This is really nice and convenient. fgdump can also be run over a network if it was needed. That would mean that there would have to be proper firewall rules allowed to allow fgdump to run over the network, or else it will be blocked, but this is also possible for network administrators if they need it. So to run this, I'm going to run it in the command prompt. It's also executable. You could just double click the link, but I would like to see the summary when it is finished, so I'm going to run it in the terminal. I've already gotten us to the desktop where the fgdump is located, so all I have to do is use fgdump and then hit return, and it runs. It's as simple as that. There's lots of parameters we could have added, but it was simple enough. I would just like to dump everything into files. So down here is our summary. It says it didn't fail. It ran on the local host. And as I said, there's 0 fail and 1 total successful, which is what we wanted. So the next part of this is to look at these files and see what we need. This first file is a cache dump file, which what it does is if on the network or on the machine there are rules set up so that a user has to change their password every so often. Generally, the passwords are cached on the machine so that you can't reuse passwords over and over and over again. And that's what the cache dump file is. It could contain many passwords that have been cached. We're not going to be using this because I don't have cached passwords on this machine. The second one is the pwdump file. This is the actual file that contains the passwords and the hashes. So we'll use that in a moment. And the final, third one, is the fgdump-log. This is a log file that contains everything that we saw in the command prompt, so that it could be saved for later usage if we need to relook at something that we did. So in order to get this password dump file into a file that we can use, we need to convert it to a text file. So I'm going to right click and open. I'm going to use a select program, and I'm going to choose Notepad. I'm not going to choose this option as always use the selected program because this is just for once, but we're going to use Notepad and we're going to open it. And here's where it displays all of the usernames on the left and the password hashes on the right. One of the things is, since I'm only going after one password, I can delete all the other usernames and hashes that I don't. So support, help assistant, guest, ASP.NET, and administrator. all of these are going to get deleted. So I'm going to highlight them all and delete. So here we have our Tyler and our hash. So I'm going to file and save that. I'm going to save it actually I'm going to save it to our John folder, which is where we have John the Ripper. Run, and then right here I've already created it, so it's going to be password. And we're going to save. Do you want to replace it? We're not going to replace it because I already have that folder file ready for us, so we're going to cancel out. So the next thing we do, now that we have our password, we have the same directory as our John folder. Now we're going to go there and crack the password. So we're going to change the directory to John. We're going to go to the run directory. And here in the run directory, I'll show you this is where we have all of our folders. We have our John file right here that we need to execute, and we have our password in the same directory. So there's lots of also things that we can use with the John, but we're going to go very straight out. We're just going to use John, and after the John is the executable, then we're going to tell it what to crack. We're going to do password.text. It's as simple as that. We can have lots of other commands with it, but I'm just going to use this, and it's just going to go at it and crack the password. As you can see here, it's already loaded one hash, and it's already cracked it. It took a grand total of 2 seconds, and you can see it took only one guess. The password is displayed right here as Jelly, and the username is Tyler. It's as simple as that. Thank you for listening to my presentation. I hope you enjoyed it. Again, this is Aaron Bryant. Thank you very much.